Hello and welcome to this video all about reverse percentages. All of these questions can be found on mathsupgrades.co.uk in a neat PDF file. You can also find solutions on there, but in this video I'm just going to talk through the solutions to give you some more support. The first set of questions are all non-calculated questions, and the first one is worth 3 marks. We're told that the normal price of a TV is reduced by 30% in a sale. The sale price of the TV is £350. We need to work out the original price. So in all these questions you need to find the percentage multiplier. The original amount is 100%. The new price is 70%. Since I've taken off 30%, it's been reduced by 30%. So we need to think about the multiplier, which corresponds with finding 70%. Since 70% is 70 out of 100, that is 0.7 as a decimal. So to find the new price, I need to do the inverse of multiply by 0.7, which is divide by 0.7. So 350 divided by 0.7. Now to do this without a calculator, what I'm going to do is I'm just going to multiply the numerator by 10 and multiply the denominator by 10. That would give me 3,500 divided by 7, which is £500. So that question there was worth 3 marks. Question 2. Jules buys a washing machine. 20% value added tax is added to the price of the machine. Jules then has to pay a total of £600. What's the price of the washing machine with no VAT added? So like with all these questions, I'm going to set it up in terms of the original price. When I multiply by the percentage multiplier, I get the new price. The new price I'm told is 600, and I'm told that 20% is added to the original price. In other words, the original price was 100%, add 20%, so the multiplier is 120%. 120% is the same as 120 parts out of 100, which as a decimal is 1.2. So I need to do the inverse of multiplying by 1.2, which is dividing by 1.2. So I need to do 600 divided by 1.2. This is the same as doing 6,000 divided by 12, which is 500. So the answer is £500, and you can always check this answer by increasing it by 20%, and that gives you back to £600. That question there is worth 2 marks. Question 3. In a sale, the price of a cooker is reduced by 50%. At the end of the sale price of the cooker is increased by 50%. Betty says the cooker is now the same price as it was before the sale. Is Betty correct? Explain why. In these sorts of questions, you can always put in a value, an imaginary value, for the price of the cooker. The original price of the cooker, imagine if it was just £100. So £100 reduced by 50% is the same as multiplying by 0.5. And then increasing by 50% is the same as multiplying by 1.5. So imagine if I do 100 times by 0.5, which is 50, and then times by 1.5, which would be 75. Now, since 75 is not the same as the original price, we can explain that Betty is definitely incorrect. She's wrong. I've written here a little note of explaining what I should have done to get back to 100%. What she should have done is realise that 50% times 200% actually gives you back to 100%. If you just times it by 150%, you only get 75% of what you originally started with. That's known as a reasoning question, and that question there was 2 marks. You can put any value you want to in this original amount and just see if you get back with the original amount in your answer, and you'll see you don't, no matter what you start with. In question 4, this is another reasoning question like question 3. In a shop, all normal prices are reduced by 20% to give a sale price. The sale price of a TV set is then reduced by another 30%. Mary says that 30 add 20 equals 50, so that means that the normal price of a TV set has been reduced by 50%. Is Mary right? And you must give a reason for your answer. This question's 2 marks. So first of all, let's think about what this means. This is saying prices are reduced by 20%. So if you take 20% off, then you're left with 80% of what you started with. So the multiplier here would be 0.8. Same thing here. If you're reducing by 30%, then 100% take away 30% would be 70%. So the multiplier here is 70%. So here's our multipliers. I'm now going to apply these to an imaginary value for the TV set. We're not told of a value for the TV set, so let's find an imaginary value, and the easiest value to work with is just £100. So imagine if I had £100, £100, and then finding 0.8 of it and finding 0.7 of it. This would be the same as finding 0.56, so the TV would now be worth £56. Since 56 is not equal to 50, we know that Mary was incorrect. Essentially, we've done this. We've said that 70% or 80% is 56%. If she wanted to find 50%, she should have multiplied 80% by 62.5. That would actually give you 50%. You're not expected to give this part of the working out in your answer. This, which I've written in blue, is fine for 2 marks. Okay, the remainder of these questions in the booklet are all calculator questions. Question 5 is worth 3 marks. Claire's making a loaf of bread. The loaf of bread loses 12% of its weight when it's baked. She wants a baked loaf of bread to weigh 1.1 kilograms. Work out the weight of the loaf of bread before it is baked. So this question again involves reverse percentages. The information I've underlined is what's important here. It loses 12% of its weight. In other words, what's left is 100% subtract 12%, which is 88%, and is a multiplier that's 0.88. This is what she wants the final weight to be. She wants the final weight to be 1.1 kilograms. So we need to do the inverse of 0.88 and the inverse of multiplying by 0.88 to work out the original weight. So that is simply 1.1 divided by 0.88, which is 1.25 kilograms. We can always check this answer by finding 88% of this, and that should get us back to 1.1 kilograms. That question there was worth 3 marks. Question 6 is worth 3 marks. In the sale, the price of a TV is reduced by 25%. A week later, the sale price of the TV is reduced by another 15%. The price of the TV is now £293.25. We need to work out the price of the TV before the sale. So what's happened here is a percentage multiplier has been applied, and then a different multiplier has been applied to get a final price. So in essence, this is how we're setting it up. The final price is £293.25. The first multiplier here, since it's been reduced by 25%, that means that 75% is left, so the multiplier is 0.75. The second multiplier here, well, it's been reduced by 15%, so the multiplier here is 85%, 0.85. So I need to do 2 steps here in my calculations. I need to do £293.25 divided by 0.85. Then when I've done that, I need to divide that final answer by 0.75 to give my final value of £460. Again, I can apply 75% and then 85% to see if I get back to £293.25, and I do. So that question there was worth 3 marks. Question 7. A shop has got a sale on. A microwave oven has a sale price of £90. A combination oven has a sale price of £84. And I'm told here in these boxes what the offers are. So for microwave ovens, it's a third off the normal price, and combination ovens is 40% off the normal price. I need to work out which of these ovens has the greatest normal price. So in essence, I'm doing a reverse percentages question here and a reverse percentages question here. So let's set it up. First of all, a third off is the same as 33.3% off. So in other words, I need to find the multiplier, I need to find 66.6% of the original price to get the sale price. As a multiplier, 66.6 recurring percentage is 0.6 recurring. So the original times 0.6 recurring is 90. So let's do the inverse of multiplying, which is dividing. So 90 divided by 0.6 recurring gives us £135 for the microwave ovens. So that's the original price of the microwave ovens before the sale. For the combination ovens, it's a little bit more straightforward because it doesn't involve fractions. So it says it's 40% off the normal price. So the normal price is 100%. If you take off 40%, you're left with 60%. So the multiplier is 0.6. Again, the inverse is divide. I'm going to do the sale price, 84, divided by 0.6, which gives me 140. So which of these ovens has the greatest normal price? So the greatest normal price is given by this type of oven here, the combination oven. And I've even told the difference here of £5. You know the answers are probably correct here because they're very close to each other, so that gives a good indication that I've got it right. Question 8. Katie invests £2,000 into a savings account for 3 years. The account pays compound interest at an annual rate of 2.5% for the first year, X% for the second year, and X% for the third year. There's a total amount of £2,124.46 in the account at the end of the 3 years. Work out the rate of interest in the second year. And that first part there is worth 4 marks. So this question not only involves reverse percentages, it also involves compound interest for this part of the question here. So if you're not sure on compound interest, you can look at my video file on this channel on compound interest, and that should give you a lot of support. So compound interest involves this formula here. The new amount in the account is equal to the original amount times by the multiplier to the power of the time period. The time period here is 3 years. So in year 1 it's just 2,000 times 1.025, which is 2.5% as a multiplier, which is £2,050. So in year 1 is 2,050. That's fairly straightforward. But in year 2 and year 3, I've got an interest multiplier here, which has been applied twice, and I need to find this. I need to find this interest rate. The interest rate, since it's a percentage, I've set it up like this. I'm told that the amount in the savings account at the end of the 3 years is £2,124. So that's equal to the amount I had in year 1 times by that interest rate there. It's set up as a percentage. In other words, if it was 1%, it'll be 101 divided by 100. If it was 5%, it'll be 105 divided by 100. So this, in essence, is how I'm turning that percentage rate into a decimal, into a multiplier. And I've got the power here of 2, since this percentage rate is applied for 2 years, both the second year and the third year, so it's 2 years in total. So now this is like an equation, and I need to solve this equation. To solve this equation, I need to isolate x by itself. So the first thing I'm going to do is I'm going to divide both sides of this equation by 2050, since that's the inverse of multiply. So dividing both sides by 2050, I'll get this line here. Now I just work this out with a calculator. That gives me 1.036. 1.036 is this expression here squared. So what I'm going to do now is I'm going to square root both sides. That gives me 1.018. So 1.018 is represented by this. So I can see now 1.018. I can now just multiply by 100 and subtract 100, and that gives me x, and x would be 1.8%. Just again on that, from this line to get the value, I can ignore the brackets now. I'm just going to multiply both sides by 100, so 1.018 multiplied by 100, which gives me 101.8, and then subtract 100, gives me 1.8. So 1.8 equals x, so that is 1.8%. It's 1.8% because percentage is in the question there. Part B. Katie goes to work by train. The cost of a weekly train ticket increases by 12.5% to £225. Work out the cost of a train ticket before the increase. So this is the question that involves reverse percentages. So again, I need to find the percentage multiplier. The percentage multiplier here is going to be given by 1.125, since it increases by 12.5%. So 100% add 12.5% is 112.5%, which is 1.125. So to find the original amount, I'm going to do the inverse of multiplying by 1.125, which is dividing by 1.125. So 225 divided by 1.125 is £200. Remember, you can always check this answer by just times it by 1.125 and you get back to this. So the whole question there was worth 6 marks. If you got stuck with this question, do look back at my video file on compound interest, which is on this channel as well. That will give you further support.